Hi everyone, this is Palermo here. I am going to go through the first section of chapter 10 with you. Unfortunately, my daughter is sick with a stomach bug, so I had to stay home. I'm hoping I will be there later this week though. So today we'll cover section 10:1. We actually are not doing all of the pages in this packet, or all the parts of it anyway, so just make sure you pay attention when I'm going through it. Also, if you feel like you want this video paused at any certain point, please just ask your sub to pause it for you. So, because of the fact that we're not necessarily doing everything in this whole packet, your homework will be shortened a little bit, so I'll tell you that at the end of the video. So a circle, we all know what a circle looks like. Here's the actual definition of a circle. It's the set of all points equidistant, and that word means exactly what it sounds like equal distance from a given point, which is the center. We name a circle by its center point. So I'm just going to add a point on here in the center of the circle, and points are always named with capital letters, so I'll call that point A. Therefore, this would be circle A. Sometimes when people are naming circles, you might see it written like this, also meaning circle A. So a radius is a line segment connecting the center of a circle to a point on the circle. So you would just connect that center to any point on the circle. And then because it's a line segment, I would, for example, call that AB. Every radius of the circle has the same length because that's an equal distance. That is like the definition of a circle. The next word here is chord, probably not used quite as frequently as radius. So a chord is a line segment connecting any 2 points on the circle. So the key word here is any 2 points. It does not have to go through the center. So here, for example, would be a chord. I'm going to call that chord CD. So again, because it's a line segment, we name it just like a line segment. A diameter is also a line segment. It connects 2 points on the circle, and it has to go through the center. So this is kind of key here. So a diameter is always going to be double the radius. And I know you probably know that, or you knew that at one time. So here's a reminder. I'm going to make that center A again. And this diameter just has to be a line segment that goes through that center. So there we go. We can see that it's composed of 2 lengths of the radius. So there's one, there's another one. That's why it's equal to 2 times the radius. If I called this E and this F, then that diameter would be called EF. Secant. This might be a new word to you. A secant is a line, not necessarily a line segment. It's a line that intersects the circle at 2 points. In other words, it's an extension of a chord. This does not need to go through the center, so any 2 points. Remember, for lines, we can name them with either any 2 points on them or a lowercase letter. So, for example, if I put a lowercase m right there, I could call it line M. Or if I picked any 2 points on that, probably the points on the circle itself, and I called those G and H, I could name that secant GH or line M. A tangent, this might also be a new word. It's a line. We did do tangent in the context of triangles, like the TOA part of SOHCAHTOA. This is like totally different. A tangent line for a circle is a line that intersects the circle at one and only 1 point. A tangent line never enters the interior of the circle. So I'm going to just put a point on here, and then when I draw the line, it's kind of hard to draw this sometimes, but it only touches the circle at that 1 point. So it just touches it. It doesn't necessarily like cut through the circle. It never goes into the circle. Similarly, it's a line, so I can name it with 2 letters. I could put another point on that line and then name it. Or I could use a lowercase letter. So I'm going to call this JK. And then if I want to name it, I could call it JK. Or I could put a lowercase letter there and call it that. Point of tangency is the point where a tangent line intersects the circle. I'm just going to use the picture from up above because it's already there. In this case, this point of tangency would be point J from above. But really, we could draw a tangent line at any point on the circle. So there's J. So this is just kind of practicing to make sure that we understand the vocabulary. So it says, tell whether the line, ray, or segment is best described as a radius, chord, diameter, secant, or tangent of circle C. That's how you read this out loud, circle C. So AC. I'm actually going to give you guys a minute. Why don't you just try this real quick? Hopefully you can kind of answer those questions without maybe looking at the first page, but if you need to look at the first page of your notes, it's there for you to use as a reference. So go ahead and try those. Just identify which word it is. Okay, so AC connects a point on the circle to the center. So that is the definition of a radius. So that's a radius. AB, that looks like a diameter. It's a segment that goes through the center of the circle. Ray DE, this is interesting because we didn't necessarily talk about a ray. But if I were to highlight this ray DE, it's just this right here. That would be a tangent. Even though we define tangent as being a line, it could also be part of a line. So a ray is just part of a line. It's tangent to the circle at B. It only touches the circle at B. So a tangent only hits the circle at that one point. And then AE. That is a line. It intersects the circle at 2 points, at A and at G. So that is the definition of a secant. Intersects the circle at 2 points. It should be radius, diameter, tangent, and then secant. This next part we are actually skipping, and I don't think we're going to go back and do it at any point, so you can just kind of leave that blank. Therefore, we're also we're skipping the corresponding parts on the homework. I want you to go all the way to, I believe this is on the 3rd page, where it says tangent to circle theorem. That's where we're going to start filling it in again. So tangent line to a circle theorem. This is kind of a important theorem in geometry. It tends to be used quite frequently. So a line is tangent to a circle if and only if the line is, just kind of like it shows you on this picture. This is your tangent line. It's tangent at point A. It only touches the circle at that point. It is only a tangent if it's perpendicular to the radius drawn at the point of tangency. So the key word there is perpendicular. We can see that it's perpendicular on this picture because it's marked with that box showing that it's a right angle. It's a 90-degree angle. So what we're going to do here is we're going to use this theorem to see if the line is tangent. So in order to see if it's tangent, we need to see if that's a right angle. So to see if it's a right angle, we can use the Pythagorean theorem. If it makes the Pythagorean theorem true, then it's a right angle. So to determine whether a line is tangent to a circle, do the Pythagorean theorem to verify the right angle. So it says, is ST tangent to circle P? So ST, it looks like it is, right? It looks like it just touches at T. Sometimes it's kind of hard to draw tangents, but to me that does look like a tangent line. But in order to see if it actually is a tangent line, so the theorem says that if it's a tangent line, then this and this are perpendicular. Therefore, then there would be a right angle right here. So I hesitate to put that box because we don't know if it's right yet. We'll only know if it's right by seeing if the Pythagorean theorem is true. So in the Pythagorean theorem, these would be your A and B. Your hypotenuse is the longest one, which is C. So it'd be 12 squared plus 35 squared equals 37 squared. So if that's true, the answer is yes. So 12 squared is 144. Hold on, I don't have a calculator handy. Just one second. If you guys don't have a calculator yet, you might want to go grab one. So 35 squared, let me get my app. 35 squared is 1225. 1225. We just want to see if that equals 37 squared, which is 1369. So we're just seeing if that's true. So 144, just verifying it. Definitely true. So it's yes, because it makes the Pythagorean theorem true. So the answer to the question is yes. This next one says, is segment AB tangent to circle P? Certainly looks like it is. It looks like it just touches at A. But again, in order to verify if it is, we need to see if these two meet at a right angle. So potentially we're seeing if there's a right angle here. There's a little note over here, which does pertain to this problem. It says, remember, all radii are congruent. So the thing is, on this triangle, they don't show me how long the hypotenuse or the potential hypotenuse is. But remember, because all radii have the same length, this would also be 11 because these are both radii of the circle. So that means that this whole segment, which could be the hypotenuse, is 16. 11 plus 5 is 16. Sorry, that's a weird looking bracket. But so then we're going to plug into the Pythagorean theorem again to see if a squared plus b squared does in fact equal c squared. So 11 and 14 are the legs, and then the segment that would be the hypotenuse is 16. So we're seeing if that's true. 11 squared is 121. 14 squared is 196. 16 squared is 256. So we're just seeing if that's true. That's definitely not true. 121 plus 196 is 317. Does not equal 256. So this is a no. It is not. We can also use this theorem to find a radius. So it says, in the diagram, point B is a point of tangency. Find the radius R of circle C. So I want to find the radius R. So I want to plug into a squared plus b squared equals c squared because it tells you that because B is a point of tangency, I know that these are perpendicular. So just keep in mind that this whole segment is R plus 50. So we're actually going to have to review something from Algebra 1 here. So my A and B are my legs of the triangle, so the two that meet at the right angle. So AD and R. These two are the legs. And then I want to see if that, or I know that that equals R plus 50 squared, and then I have to solve it. So 80 squared is going to be 6,400. I know that because I know 8 squared is 64. And then it would have 2 more zeros plus R squared. Okay. Next, this is probably like the most common math mistake ever. That does not equal R squared plus 2,500 on the right side. It does not. You have to go like this and realize that to square something, it means to multiply it by itself. You have to do something that you did in Algebra 1 last year. You might have called it FOIL, stands for first, outside, inside, last, or you might have just called it the distributive property, but basically you need to distribute this to both of those and this to both of those. So on the left side, for now, it stays 6,400 plus R squared. On the right side, R times R is R squared. R times 50 is 50R. 50 times R is also 50R. And those are positive, so I'm putting the plus. 50 times 50 is 2,500. Now, both sides of this equation have an R squared, so really you could subtract that from both sides and it would go away. So I'm just going to cross it off. So we have 6,400 equals 100R plus 2,500. So 6,400 minus 2,500 would be 40, weird math. I'm erasing that. 6,400 minus 2,500 would be 3,900. So you have 3,900 equals 100R. Divide by 100, divide by 100. I'm getting R equals 39. You could, of course, plug that back in and make sure it makes the Pythagorean theorem true. I'm not necessarily going to do that right now, but you could. So there's a couple of U-tries right here. Right now, what I want you to do is pause the video, and you're going to try those, and then I'll put the answers up. Later, I will upload a key to these notes, and it will be all filled out as well. Okay, so here are the answers to the U-tries. So the first question is asking, is DE tangent to circle C? So if DE is tangent at point D, that would be the point of tangency, then CD is perpendicular to DE. So to check that, I did the Pythagorean theorem, plugged into that, and it did end up being true, so the answer is yes. The next one tells you that you have a tangent, which means that the Pythagorean theorem is true. So you can use that to find the radius. So in this case, I started out by labeling this hypotenuse as r plus 18, and I plugged into the Pythagorean theorem. These two that I'm highlighting in pinkish purple are the legs. So they go in for A and for B. And then the hypotenuse is C, and it's r plus 18. Remember, to multiply that, you distribute. You actually end up getting 4 terms when you distribute. The r squareds cancel because they're on both sides, and then you just solve that equation for r. I ended up getting r equals 7. If you need to pause it right here to copy this, that's fine. It is also going to be on Google Classroom later. So then just to finish this up, we have, let's see, about one more page left. So we have the external tangent congruence theorem. It says if two segments from the same external point, in this case, the external point is B, meaning outside of the circle, are tangent to a circle. So here's a tangent segment, which could be extended to a tangent line. Here's another tangent segment, same thing. It initially was a segment from B to A, and I extended it to a line. But if we have two tangents coming from the same external point, then they are congruent. So this blank is congruent. So we're just going to use that to solve some equations. So in this picture, I know that AB would equal BC. So using that idea on this first example, it says RS is tangent to circle C at S. It's a point of tangency. Here's another point of tangency coming from the same external point. So therefore, we know that those segments are congruent. We can use that to find the value of x. We have 8 equals x. You can always plug that back in just to make sure it works. 3 times 8 plus 4 is in fact 28. So they're both the same, so it does work. On the bottom one, actually this ends up being a quadratic equation, meaning it ends up having an x squared in it. And you have to probably factor it to solve it. We are not going to review that today, so we can hold off on that for now. Let's see. Oh, this is perimeter. Okay. So in the figure below, the sides of the triangle are tangent. That should say tangent. Typo. Tangent to circle J. Find the perimeter of triangle DEF. So this is using that external tangent congruence theorem. And I'll show you how. So from this point E, this is tangent to the circle at H. This is tangent to the circle at I, so they would be the same length. So therefore, this is 16. Also, this segment is tangent to the circle at I. This segment is tangent to the circle at G, so those would be the same. So that's 9.5. From D, we have this tangent segment at G, this tangent segment at H. Those would be the same, so that part's also 11. So to find the perimeter, you always add all the way around. So you really just add all these numbers together. So the perimeter is going to be 11 plus 11. That's your perimeter of the triangle. So let's see, this would be 22, this would be 32, and this would be 19. So 22 plus 32 is 54, plus 19 is 73. So the perimeter of this is 73. There's no unit, so I'm just going to put units. Okay. There's some U tries down here using that same idea. So same thing, I'm going to have you pause this for a minute, give those a try. And you should be able to do all of them, actually. And then I will put them up and quickly go over them. Okay, so I'm just going to start the video back up before I finish the last one. So on the first one, I just ended up setting up the equation. I know that these external tangent segments are equal. So I know that 7x minus 23 equals 61. Just solve that for x, and you end up getting x equals 12 for your final answer. The next one right next to it is the same idea. These external tangents are both coming from A, so they must be equal. So 2x squared plus 4 has to equal 22. I'm going to explain the solving of that really quick. So I subtracted 4 from both sides, and I had 2x squared equals 18. I wanted to solve that for x, so I divided by 2. I had x squared equals 9. Solve that for x, so you want to get rid of the squared, so I square rooted both sides, and I ended up getting x equals 3. Actually, negative 3 would also work, now that I'm thinking about it, because if you were to plug negative 3 back in here for x and square it would also end up working. So, sorry, that should be plus or minus 3. Generally, when you're solving those types of equations, you might remember from Algebra 1, hopefully, that you put a plus or minus in front of it. Okay, this last one, I just wanted to kind of explain live before I just wrote the answer because it is a little strange. So I knew that this whole side was 52.5. So I took half of that. 52.5 divided by 2 is 26.25. So this part right here must be 26.25. Therefore, so is that, because they have to be the same. Then this is 27.1. Okay, sorry about that. I actually just realized that I made a mistake, so I need to fix this. So I'm going to go back and fix this again. I don't know why I did it like that. So this whole segment right here is 52.5. This part of it is 27.1. So this part right here would be 52.5 minus 27.1 for the green part. So that's 52.5 minus 27.1, which would be, okay, sorry, I don't have a calculator right here. Whatever that is this green part right here. And then this part's also the same. This is 23, so this is 23. This part that I'm about to highlight in yellow would be 37.5 minus 23, which is 14.5. And then this yellow part would also be the same. So we just need to find the perimeter of the whole thing. So we're going to add all the way around. And I will finish that for you once I get a calculator. My mental math is struggling right now. Okay, so I did end up taking 52.5 minus 27.1, and I got 25.4 for right here. This is also 25.4. So this is what I got for the perimeter when you go all the way around the shape. So this, hold on, I started right here actually. 14.5 plus 14.5 plus 27.1 plus 27.1 plus this was 25.4 plus 25.4 plus 23 plus 23. And whatever that is the perimeter. I will load that on the answer key to the notes on Google Classroom. There are some problems on the homework that you can skip, so just make sure you listen to the sub in terms of which ones we didn't cover. You'd probably be able to figure it out. And have that homework done on Friday when I see you. You should come into class with it being done. I will see you then. Bye.